Can you hear me all right? Okay, great. Hi everyone, thanks for joining this session. My name is Nicolo, that is Marion, right there is Sam. They're teaching along with me this introduction to Git to version control using Git and GitHub course. Some preliminary information. So this is the course material. So basically here you can find the slides. This QR code will bring you to the repository page. We assume that you've gone through the preparation. Hopefully, if you haven't done that, please have a look into it and try to skim through it and see whether you have any problems. If you have any problems with setting that up, just ask for help and we'll try to see whether we can get you up to speed and follow along, as we will have some practical part in the course. Okay? All right. So in this course, we will try to get you familiar with version control, what it is, to understand why it's useful, and try to make you see some practical use cases of Git, and do some exercise to get up to speed with Git and use it promptly in your projects. Right. So as a kind of motivation, there's this really from PhD Comics, this comic that shows up a really fairly common situation with when you're developing your software, just writing your documents, when you're passing it over with your supervisor or with a friend who is helping you work on that. So, but even if you're not even collaborating with other people and you're just working on it, you tend to create, without using version control, you tend to do it manually and create many copies of the same documents, which will get messy real soon. So that's why version control exists. So tools like Git and GitHub try to help you in this case. So which help you to actual version control the code and the documents you write in general. And if it's useful even if you work alone. So hopefully after this course you'll understand that it's useful even if you work alone and not just in a collaborative setting, even though as scientists or promising scientists you will certainly work in a team, so that's really useful to know. So to this end, version control systems have been developed. With our version control systems, they are tools that allow you to track the changes in your code, and every version control system that was created has a different way of doing that. We will be focusing on Git, but just for the historically, Git was not the first one that was created. We go back to the 80s when the first version control systems were created, and progressively there were a lot of other ones that got in place. But so what do these version control systems do? They allow you to go back to a previous state. So if you say screw things up, you'll be able to go to a previous version of your code. So that's really useful. They facilitate collaboration. So if you're working on code with other people, it's extremely not only beneficial, but it's quite mandatory, because otherwise it's really hard to work and collaborate well. And all of these benefits come with very little overhead. So why Git then, among the several options out there? Well, Git is a very mature tool. So it was developed in around its development started in 2005 from the creator of Linux. So it started. So it was thought of to be used in a very complex project. So it's not just a toy to play around, but it was thought of from the very beginning to be used in to large scale. Git is absolutely ubiquitous in the open source community. So it's if you will be working with open source, which as scientists you'll probably do, then it's something to absolutely know. It uses a distributed version control approach, which is very beneficial compared to other version control systems, they use a centralized approach where all the changes are tracked from a centralized instance where that keeps track of all snapshots of your projects over time. So basically a different status of your project over time. And if that, say that instance on a single server goes down, then all the people working on that are not able to. So whereas Git uses an approach that is called distributed. So every person that uses Git on to work to version control their code have their whole history of changes of their code on their local machine. And so what that means is that if you end up, deleting, which can happen, by the way, the whole history of your project, that doesn't mean that another person that has the whole history will have it deleted as well. So Git is a really powerful tool and allows you to have a very fine-grained control over how you version control your system, your code. Well, GitHub is a really different tool, so people, especially beginners, tend to confuse Git and GitHub. But GitHub is a really different thing. It's a code hosting platform, and it allows to store online Git, what is known in Git jargon as repositories, which are just folders that are tracked by Git, that are version controlled by Git. And it's if you're using open source projects software, then the likelihood of you having used GitHub or at least visited GitHub is very high, since most of open source projects are hosted on GitHub. It's not the only code hosting platform that is out there. There are others, Bitbucket and GitLab, and there are many others. And but in the open source world, which is the one that we mostly care about, it's really ubiquitous. GitHub introduces concepts like pull requests that, no worries, they will be discussed later. And so it adds concept to Git to ease the collaborative development idea. Also allows users to discuss on code, and so that's really useful for collaborating. And it also provides more advanced features to automatically test your code, and also to do other kind of automatic security checks on your code. There are a lot of, you can host, for instance, a repository. GitHub allows you to have what is called as a GitHub page, so allows you, for instance, to have your website, so your code deployed as a website for free. And there are many options out there, and you will certainly explore them on your own. So in today's course, we will try to create a local Git repository. So this is all Git jargon that we're going to clarify in a bit. And so this is what we're going to do practically. So this comic is quite representative of the experience that many people, especially beginners, have with Git. So you tend to, blindly learn very few commands and without really understanding how it works. And then at some point, when you see that you get the results that you were not expecting, then you just delete the whole thing and start from scratch, which is something that you hopefully won't need to do if you have ever used Git before after this course. Right. So let's start with some basic concepts in Git. So a repository is a folder on your machine that you want to start tracking, where you want to put your work, so your software, whatever, your documents. And it's identified by this .git folder, which we will see in a second practically, since we will now to a practical session. So I invite everybody to pull out their laptop and open a terminal session. So we put in the preparation, you should have gone through already some of the steps through the preparation, so you should be familiar with that. But if that's not the case, please just don't hesitate to ask, and just interrupt me if you have any questions. Really, there are no stupid questions, so please ask. Right, so we open a terminal session. Okay, you see it's fine. Yeah. So we first go to a location where we want to put a new Git repository, so where we want to store our code. So I want to list the file where I'm in. So this does print working directory, so I want to see where I'm at. So here I want to create with the Unix command make dir. I want to create a new directory called intro-git. So after having created that, I will change directory, that's the Unix command, to and make sure I actually change directory. So now you can see if I print a working directory, I'm actually in this new directory. And here is where I'll place the code I want to actually version control. So, well, first of all, let's go back to the slides. So we are at this stage. We want to initialize our tracking with Git. So what we do is we run Git init, and then we pass also this option that tells how to call the main branch that we'll be using, which is a concept that we will talk about later, but don't worry about it for the minute. Okay, right. So it says correctly. So if you've done everything correctly, you'll see that it says you have initialized an empty Git repository because we don't have any actual file within it. Right. So how do we know whether we have, I mean, apart from this message, how do we know we actually created a repository? Well, if we list all the files, we have to pass the -a option to show all, even the hidden files, which are the files that on Unix systems have start with a dot. We see that we have, so it's not empty anymore, but we have a folder, a directory that is called .git. Okay, and if we try to see what's in it, so we do ls.git, we list all the files, we see there are a whole bunch of files. Don't worry about it. Git is very has a specific data model, so it doesn't store all of your files in plain text. So it's very efficient in the way it does that. It has a specific way of storing files, and this is the proof. So you see the objects and the references. So these are the main concepts in the Git data model. You see the config, which if you've gone through the preparation, you should be already familiar with, but it contains all the configuration, the current configuration for this Git repository. For instance, if I run git config list, so here I see all the current configuration. Don't worry about many of them, we won't use them, but if you followed the preparation, you should have already set up you should have already configured Git with these options. So you should have specified a name and an email. Okay, so now we are at the stage where we have created our repository, and then it's now time to actually learn what one of the most important concepts in Git, that is a commit. So we said that in order to version control your repository, Git needs to create snapshots at different point in time. So you want to save the state of your project at a certain point and give a label to it. So that's exactly what a commit does. So you want to say, okay, save the state of the repository at this time. And then a really cool thing that is allowed by the Git data model, which is Git keeps a graph of all your commits. So stacking them up. So if you do a commit now and then a commit later, the commit that you do later as a parent, that is the commit we've just done now. So it has this this graph that is handled by all the files you see in the .git folder. So all those files take care of the complex things that Git is doing under the hood, and so it allows you to switch between different versions of your work because you can move between commits at any point in time, and it's very efficient in doing so. So, well, committing is a three-stage process because there's a concept. Do we have the photo? Yeah. It's a three-stage process where you first start by having a file, okay, in what is commonly known as the working tree. So this is just a way in Git jargon, basically the directory where you're working. You have a file there, which we will create now. Do we have? Yes. Okay. So we will now create a new file. Touch is the Unix command to say, okay, create a new file. And then we're going to call it, with a lot of fantasy, new.txt. Okay, if we now do ls, we list all the files, we see we have this new.txt. Okay, so this file is here in the working tree. We currently have it. So this is the stage where we are at. Now, this is an empty file. So we want to actually yeah.
Windows equivalent of touch, like do you also in slides?
What's the equivalent for the Windows terminal? I'm not. Do you know what's the Windows? Which shell are you using? Are you using PowerShell? PowerShell, so it doesn't have touch. Sorry, I'm not familiar enough with Windows shell to. But you can also, so you don't have to use Vim as so this editor. So you can just go to your file explorer, create a file that way. It's exactly the same concept. Okay, that's not what you know. It's what matters here. Okay, okay. So now I'll use this editor, but you can use whatever editor you want to modify your file. We want to modify our new file, new.txt. So as I said, really, you can use whatever editor you want. I'm using Vim because it's the editor I use, but most importantly because I can stay in the command line. And I now want to insert a couple of phrases and modify my documents. So I then save it. And now I'm at this point. So I'm still at this stage, so I'm in the working tree. But now my file is in a status that is called untracked. So now Git is not, it knows that there is a file, but it's not tracked. So what we want to do now is we want to move forward. So we want to move to the stage where we actually move our file. We want to move towards committing this file. So when you commit the file, you actually record it in Git. You record the status, you take the snapshot, as I told you. And so what you want to do now is to add this file to Git add. So you want to move it to the staging area, what is known as the staging area. So if I do git add new.txt, what I've done now is I added it to the staging area. And there is a really useful command that is called git status. So this is I would call it non-destroying command. You can run it at whichever point you want in a Git repository. It won't break things up. It will just show you what is the current status of your repository. So if we now run this git status, so it will give you relevant information. We see. So this is the branch, which we'll talk about in a minute. And we don't have any commits, so there's no snapshot of our work just yet. And but you see this color, so we have this green color that identifies a file that is in the staging area because we added it to Git. So before adding it to Git, it would have been red, so which means it's still untracked. And so this file is now ready to be committed. So if I now do git commit, I have several options actually. I can show you. So this is what I want to do. So I want to commit the file. So here we show a way of committing a file. So creating this snapshot that is passing this -m option and then a commit message. So what happens behind the scenes is that every time you commit a file or create this snapshot, Git assigns about 40 hexadecimal digits code, hash, it's called hash actually, that identifies your commit that is generated by Git. But we need to actually also put a human readable message. It's a label of what you just committed. So at this stage of your project at this time, and it's really important to give a meaningful name for what we have just done. Of course, we just created a file that is called a new .txt with content hello world from Cambridge. So a meaningful commit message in this case could be greeting from Cambridge. But of course, in your software project, you'll be in a more serious situation. So if we do that, we see that we have this output saying this is the root commit. As I told you, Git in the Git data model, Git uses a graph. So this is the root node of the graph, and then all the new commits will stack down from that, will be the children nodes of this graph. And then it says, so records, this is the very beginning of the hash code, the unique code that uniquely identifies the commit. This is the commit, the human readable commit message. And one file's changed, 2 insertions. We have changed just 2 lines. These are the lines we changed. And so if we now run git status, which is, as I told you, a command that you can always run just to make sure you're not sure what's the status of your Git repository. We see there is nothing to commit. The working tree is clean because actually the only thing we had in our working tree has been added to the staging area and then committed. So actually recorded by Git. So the last thing I want to talk to you about is Git logs, but first let's try to add another line to this file, so another commit. So let's say from Cambridge, UK, so identify the real Cambridge we're in. Right, so now if we run git status, we see, as I told you, this is red, so it's not in the staging area just yet. The file has been modified. So at the very beginning, the file was untracked before adding it to the staging area, but now the file is tracked by Git at this point, but it's modified. So there's a difference between, maybe I should go back to the slide if it was not clear enough. So untracked is when you create a new file and you haven't told Git to start tracking it. that was the case when we created the new file, a new.txt. Now the file though is modified. And so because we have created this new line that is get Git records in the working tree. So what we now do is we do the same command. So we add this new line. So we run git status, now it should color in green. Okay, so it has been added to the staging area. And then now we commit it. I now just for educational purposes want to show you another way to commit. So if you don't pass the -m and then the commit message, that is the inline way to do that. If I just say git commit, then it will open my editor of choice. Among the configuration option, you have an option that is called editor. So you can tell Git what you want your default editor to be used by Git to be. In my case, it's Vim, but you can go through in the preparation. There is the link how to set it to whatever editor you're most familiar with. Let it be Visual Studio Code or Notepad, whatever. And then I'll create, and here I can write the new commit message. So I can call it specify country. If I now save, so of course the interface you'll have will depend on which editor you're using. So I have the feedback saying I have created this new commit. So if I run git status again, I'm in this situation. Now, last thing I want to show you is how to, what is git log? So git log is a powerful tool for inspecting the snapshots of your repository. So it will show you the hash, the full hash that I told you identifies every commit, and then all the relevant metadata associated to your commit. So you see the date and the author and the commit message. There is one really handy option that is called, if passed, that is called graph, that will actually show you what is the graph dependency. So which commit is, so this is a parent commit to this one. Of course, this may seem really trivial because it's just two commit, and we haven't properly talked about nonlinear development, nonlinear version control, which is done by branching, which Sam will talk about in a minute, where you'll have more complex structures. But it's really useful, in the project you will be working with, will be certainly useful. All right, so now Sam will step in to talk to you about branching. Yeah, exactly. Yeah. Have you successfully, so have you committed the greeting for Cambridge? So okay, so now you've opened it again and you modified it. So if you run git status, what do you see? I can, yeah, I can do it. Sorry, I can just have a look. Oops, sorry.
All right, so I hope you've understood a bit of that so far. So now we've looked at some of the basics. So what is a commit? So you should now know what we've done so far. So far I've created two commits, but now we want to talk about branching, which as you can see in this allows sort of parallel work to be going on at the same time. So a branch is actually pretty simple. It doesn't really introduce anything new. All it is a label that points towards a commit. And then as you create new commits, that label for your branch will update to follow the latest commit. And so far we've been working in the main branch. So we started off, the main would have pointed to commit 1, and then as we made a new commit, main now points to commit 2. However, we're able to create new branches, and this therefore allows work to be ongoing inside one branch at the same time as work is going on in another branch, which is particularly useful for collaborative work, as you might be able to imagine. So the way this works is you first need to create a new branch. So initially, you'll have your main branch pointing towards your current commit here, your most latest commit. What you can then do is create a new branch, and that will also point towards your latest commit. So you'll have two branches pointing towards the same commit. However, then as you create new commits, only your new branch will follow that new commit. Whereas if you were to then swap back to your main branch, you can create commits from there, and you would end up with a result that looks like this, where there's multiple parallel branches going on at the same time. So let's give this a little bit of a go. So you can do this by creating a new branch using the git branch command. But you'll still be in your original branch. So you would then need to switch to the new branch, which can do git switch to your new branch. But conveniently, and pretty much every time you'll want to do this when creating a new branch, there's this convenient command you can use, which is git switch, and then use the option -c. Should use this instead. That's a bit more easier. So the git switch -c and then your branch name. This will create a new branch and switch into it at the same time. So let's give that a go. Yes. So if we want to create a new branch called new branch, in reality, you would have some name for the branch that is descriptive of what you're actually doing. Here it's just a toy repository, so new branch will work fine. So we say git switch dash, whoops, it's that one, yes, -c, new branch. So now you can see that we have switched to a new branch, that's the name of it. So let's, one thing you might be aware of, you might need to be aware of, if you're using an older version of Git, this switch command won't work. In that case, you'll need to use checkout, and instead of switch -c, it'll be checkout -b. Don't worry about that unless it complains when you try and use git switch. So now that we're in our new branch, let's create some changes in our file. So I think it was called new.txt. So let's create some changes in the new branch. So you can modify the file in whatever file editor you want. You don't need to use Vim. Where's the code log? Which one is it? Should it work now? Excellent, thank you. So I'm going to save that change. So if we call git status, we've modified the file. So again, follow the process for creating a new commit. We want to stage those changes. So we add the file, and then we make a new commit. And I'll say changes in new branch and commit. Excellent. So if we look at the log now, I'll just do log. You can see that now we've got 3 commits. First one and then the second one, that's where the main branch still is in this second commit, but we've since made a new commit and that's where our new branch is. And you can see that head, which is where we're currently working, is currently in the new branch. All right, so what about if we want to switch the branch? So let's try that. Let's give that a go. We will try switching back to the main branch. And we can do this again using the git switch command, this time without the -c, because we're not creating a new branch. We're switching to the existing main branch. So if we do that, let me exit that. So git switch main. And now, if we have a look in the new.txt file, we can see that it no longer has the additional changes that were made, right? This is the state that it previously was before we made that last change. So this is what's useful about Git. It can maintain the state of your repository in multiple different states, and so you can work on them at the same time. So then there's one final thing that we want to look at here, which is at the moment we've got 2 separate branches, but what happens if you want to combine those changes back into the branch? For that, you can use the merge command, so git merge, and then the name of the branch you want to merge in. So we want to merge the new branch back into the main branch. So we're inside the main branch already, so we just need to now call git merge new branch to merge the new branch back into main. Hopefully that's not too confusing. Oops. So cool, git merge, and then the name of our branch, which was not, that is right, is it not? Yes, there we go. So it's now merged the new branch into main. So if we again call git log, we can see now, nothing like this in the way. Oh, it's still on the way on there. So now main is up to this most recent commit. It's at the same place as new branch. So that's how you create branches, switch between branches, and merge them. Now, why and when would you want to use this? So there's a particularly useful way of working I would recommend, unless you're working in a repository that already uses some particular workflow. But this is feature branching, where whenever you're making changes to the code, to some code base, you always create a new branch, and then you can work inside that new branch. And then once those changes are complete and they're working properly, you can merge back into the main branch. So this has a number of benefits. It means that you can work on multiple things at once. So whether that's working collaboratively, people can work on different things, or even by yourself, you can work on multiple things at the same time, which you sometimes need to do. It also ensures that any work in progress is kept out of the main branch. This means you can always change back to the switch to the main branch if you need to run some code that you know is working. Because if you've got breaking code inside the main branch, then it's particularly difficult to find out where it was working again. And to go with that, it also means that you can make much more regular commits because you don't have to worry about having broken the code because you're in a separate branch. You don't need to worry about that. You can just make small changes, small commits whenever you make changes. But one thing to bear in mind with branching is, oh yeah, go. Yes, yeah, you could merge. You might have a bug fix off of a feature or something, or a feature off of a feature, whatever, and then you could merge it back in. You can have a branch that comes off of main and goes into the feature, or vice versa. Yes, it's very flexible.
And so we alterate the file and then we merge, for example, features and bug fix. Which alterations will be in our merged file at the end?
So when you create a new branch and you're then making changes in that branch, whenever you then merge that branch in, all of the work that you've done inside that branch will get merged into. Does that make sense? Or sorry.
So like last alteration made will remain, or like it depends on the way we define things?
So all of the changes you've made and all of the commits should apply. This could be an issue if you've been working on both this branch and the other branch at the same time in the same place. It will create conflicts when you try and merge it, and you'll have to try and resolve those conflicts. We're not going into detail for that here. It's not actually, it sounds worrying. It's not actually that bad. But unless you've been working on two branches in the same place, Git will know how to merge those changes just fine. And one final thing that I want to say, when working with branches, always try and keep them short. Don't have long-running branches that you've been working on for months and months and months, because at that point, it becomes almost impossible to merge it back in. And all you've done at that point is just created a fork of the code that which defeats kind of the point of having this version control, because it's just at that point it becomes two separate code bases, and that's not helpful. Is there any more questions at this point? Otherwise, we'll go on to working with a remote repository. There we go.
Has everybody managed to create their branches? Or is there anyone who needs a bit of time to get up to speed?
Yeah, it's just raise your hand. Help figure out what's going on.
I'm just thinking, that's always the question whether you want to have a little exercise on conflicts, on merge conflicts at this point, because it will come up. So if you're working, especially if you're working with other people, you will have conflicts. And I say conflicts not as a general term, but as a technical Git term. There is the technical Git term of a Git conflict. And that is exactly if somebody has gone along and has worked on the repository and had made changes. Another person has gone along and has made changes, and they will have made changes to the same file. And then you will have this point where Git asks you, okay, I've got this version and also the version that was on the main branch. what shall I do? And then you are able to see the file, and it will then mark, okay, this is this version, this is this version, pick one. And then you basically pick one and you save that file again. But if you're at this point, any one of us is happy to sit down with you and show you how to do that. But we've not included it in today's course, but we can, if you want, make up a version of this merge example that creates a conflict, and sit down with you tomorrow morning or so and show you what to do. Okay, but what we want to go on to do today is to show you how to actually use GitHub, because so far we've worked with Git, but not with GitHub. And as Nicola already said, there are GitLab and Bitbucket and so on that you can use as well, which work in a relatively similar way, but GitHub is probably the most popular repository cloud, if you like, to use. The reason we want to have something like that is that you do not want to work on your computer on your own, and that's what you've done so far. Everything that you've done so far is all on your computer. But if you're collaborating with someone, you want to have some central hub, basically, that holds your versions of the code, and that holds the branches when you're ready to put them there. And the technical term is push them there. And you also want to be able to have your collaborator push something and you pull it down from the repository, and you're able to basically collaborate on this code base together. Or you can also see this as something where you are basically backing up your code, so that if your computer, I don't know, falls in the bathtub or so, you're able to still get some version back of your code. There are two ways of copying the code from a remote repository. One is called git clone, which basically makes this local copy of that repository that is on GitHub on your computer. And if you've done that, you're very easily able to basically synchronize the online repository and the repository on your computer. And then there's what's called, I'm just reducing this here so that you can read that. If I'm able to move this. Oh, okay, never mind. The other version is fork, and what that does is it's creating another version of that remote repository in your GitHub account, and then you can do with this version whatever you like to do. And then you can make a copy of that on your local computer. So it's basically two separate versions. And I'm going to talk about that a bit longer, because that's maybe not that easy to understand. The first question we want to talk about is, do we want to clone or do we want to fork? Or when do we want to clone and when do we want to fork? And why are there these two versions anyway? The reason you might want to fork is maybe this code base that you want to work with is something that someone you don't even know has made open source for others to use. Maybe that there's someone who is happy to let others use their code, but this person doesn't want other people to contribute back to the code, or just their very close collaborators. It might also be that you are in this situation that Sam just described, where you just want to go away and work on your version of the code and don't worry about what happens in that repository over there, but you just want to take basically the snapshot of the code as it's on the main branch now, and you just want to continue working on that. you are able to contribute back, maybe through a pull request, but it's not as easy and as straightforward. And maybe you don't want that. You just want to continue and write your own version of that code base. And also then you don't have to negotiate back with that original code developer, and so about pull requests back into the code base. That code base that you forked is now your own, and you can push to that and you can change that as you like. And you might also not want any changes to that from that original code base. So you want your main branch being your main branch and staying in the version that you want it in, and not worry about that. All of that is not necessary. You can fork and still then in a way synchronize or so, but this might be reasons why you want to have this stronger separation of the two repositories. On the other hand, a reason that you might want to clone is, well, you're maybe part of the team. So you're part of the main developer team of this code base. So you may be responsible for merging things back into that code base or so. And you want this very strong close connection to the main branches. You want to receive every single update on the main branch and get it back into your code base. You will need to have permission to do that. Yeah, that's maybe it's your repository, maybe it's your direct colleagues or so, but if you're directly cloning, you need to be a part of the team, you need to be added to that repository. And that's actually the reason why I and Sam, why we went around and got all your GitHub usernames, because we want you to practice cloning, and you wouldn't be able to do that. You would have to fork the repository if we hadn't added you to that GitHub repository. And just to maybe, I hope not confuse you further, but explain it a bit further, we attempted a little graph here. So you can see here is your local computer, and here is GitHub. Here is some other user you might be working with or not working with, and here, this is you. And this other user has their GitHub repository here on GitHub. And what you can do is you can fork it into your GitHub. And then you have got this own version that's the same then as if you had created this repository on your GitHub. And then you can clone it onto your computer. So when you clone, that is the process how you get it onto your own computer. And these repositories are closely linked, so you can push and pull between your computer and GitHub really easily, whereas contributing back here is a bit more tricky. Okay, we've created this example repository. So if you could all type in this link or use this QR code, or maybe Sam can also post the link on Slack. If you're on Slack there, it's basically the same as where the slides were, just with the dash practice at the back. And that is just some silly little repository. Is it this one? This one? No, that's the one. Just a little repository that has some text files in there. It has a README file in there, and so, and we just want to use this to practice what we are doing. Oops, I'm in the wrong one now. Here. So I hope everyone was able to open that. Otherwise, let us know. I will just quickly show you this slide, but you don't need to do that. You can do that, but potentially you will have all sorts of problems later on. If you want to fork a repository, there is this button here where you can create a new fork. And that is, why is this one open? And that will get you to this screen where you have your username, and then you can give the new repository a new name, and basically create this new copy. You can also say, oh, I just want the main branch, so copy it over, or I want to have all the copies, and it tells you you are creating a fork in your personal account. You can give it a totally different name and pretend you have created this repository and written all that code. Well, there is a record of that it was forked, but that is your repository then. So if you've done this, the forked repository is in your GitHub, but only on the GitHub. And then you need to do the next step, and that is cloning the repository. And this is what you can now do with that example repository. Just a warning before you do that. You should clone a new repository to a new working folder, and never ever into an existing local GitHub repository, because then you have all kinds of problems. But what you're doing is you're not going to the fork bit, but you're clicking on this button here, and you're not going to the code spaces, but to the local bit, and you're definitely using the SSH link. Don't use the HTTPS link, use the SSH link. You will need to have set up your SSH key and so on, as it was all described in the prerequisites. And you're copying this, and then you're using this git clone and the whole bit here that this has given you when you went to the SSH bit. So everyone just have a try with that. Yeah. You should not put it into the folder you were just in, because so not in the one that already has a .git folder. So because then you've got some kind of nested repositories, and I'm actually not quite sure what Git will do at that point. Dominic, have you encountered that?
Done it, but yes, it's easy to get in a mess. Because you can just get confused where you are. It will just go to wherever the top level of Git is.
Okay.
But
yeah. If you do want GitHub repositories and GitHub repositories, there's something called subtree, Git subtree that you might want to use, but that's something else. So if you're getting kind of SSH errors, it might be that you've not done the prerequisites and added all the necessary stuff to your GitHub account. But is everybody happy so far? Maybe just one thing to add for those who are done. If you're wondering how you get a repository that you created on your computer into GitHub, the not very straightforward but easiest thing to do is create a new GitHub repository in, basically there's a create new GitHub repository switch, and then you can do something like set remote, so git set remote, I think something like that it's called, and then the link to that GitHub repository. But you can also just start with a GitHub repository, with an empty GitHub repository, and clone that, and then create basically a stuff in there. Then you don't have to do the init command though. So it is possible to have something on your computer and then push it to Git. Okay, let's continue in the interest of time. The next exercise we want to do is to now actually push something to that repository. So you have all cloned the repository onto your computer, and now there are a couple of things that you've already done in the previous exercise, so I'm not putting the commands on here, so you should know them now. And that is to create a new branch and use a unique name, because you're all working on the same repository now. So if you push that and everybody has the same name, there will be a clash. So put your own name or something silly that nobody else would think of on there. So create a new branch in the practice repository. Choose one of the files which are already in there or create a new one and then commit it. And then the next thing is you do a git push. If you do a git push for the first time in this repository, you need to do this set upstream origin your branch name. So if you do this, you have created a new branch, it's not yet in that repository. You need to tell Git basically what origin is on GitHub, basically what the branch name on GitHub is. Usually it will be the same name. You could theoretically use a different name on GitHub than you have on your local computer, but that I don't see any reason why you would want to do that. So then after that, you just, if you've done that once for this branch, you only have to do git push after you've committed. So we'll give you a bit more time, and if we have enough time after this, we will then go through the process of how to merge things back into the main branch on GitHub. But let's see how you're getting on with this one. So again, if you have any questions, just raise your hand and we're going to help you. Don't forget to go into that repository though. So you've cloned the repository, but you have to cd, so change directory into the repository first. Okay, in the interest of time and so that we don't all miss the bus to the dinner tonight, I'll continue with the next step. But if you've not managed to get this far, don't worry, you can grab us anytime this week and ask us to help you through the next steps. The next step, if you've done the pushing, is that you have pushed to your own branch, but you now want to go back and maybe merge your branch back into the main branch. Sometimes you can just do that. But if the repository owner says, oh, I do not want to have everyone just merging into the main branch, then they will have protected the main branch. And what that means is that you need to create a pull request and have this pull request approved before you're allowed to merge back. And what that means is that somebody else will basically look at your changes and say, oh, this looks good, or oh yeah, that is great, but oh, you've done a typo there, or oh no, this will actually break everything that is in the main branch and you really cannot push this. Yeah, and I've also just added this additional point about continuous integration, which is something that means, okay, I have set up a couple of tests which I want to be run every time somebody creates a pull request, and I will only allow people to merge into my main branch if all these tests run through. And this is a really good way if you have production code or code that is used by others, that nobody is able to actually break everything through their changes. So if you have written your tests well. Okay, I will just try to find this again. And if you have made changes, you can go here to the pull requests step. And if you click on the new pull request, there might be also, if there have been recent changes, there will something popping up here on the top that tells you about this. And then you say, oh, okay, I want to create a pull request. And then I can say, oh, here, which branch do I want to take? Let's just take one. Oh, this one hasn't made any changes. Let's find someone. Okay, here are a couple of changes, and I can actually see these changes somewhere here. And I say, okay, create pull request. I will give the pull requests some name, for example, important adaptations. And then you will write something about the changes that you've made. For example, this goes into the intermediate session. If you've created issues, you can say, oh, this fixes issue 25, and I have made all of these changes. And then you say, okay, here, this is my description. And then you can say, oh, I'm assigning this to myself, but I want somebody else to, Dominic, are you online? Somebody else as a reviewer. And this person will go and look at the changes and write a pull request review. This might sometimes take a little while. Yes, it's on 10. And yes, so that person will go and look at these changes, maybe add some comment here. And so, and then at some point when they are ready, they will go to submit review, leave a comment, and either approve or request changes. I'm not doing this on my own here because you cannot review your own pull requests. Well, you could review it, but you usually cannot say cannot remove review your own or approve your own ones. Yeah. So you see here the branch is protected, and I cannot merge at this point yet. Are you able to create this quickly? Otherwise, I'll. You've done it. Okay. Okay, so we've got a couple of suggestions, and so we might need to say something here. We can just say, oh yeah, we want to actually, this is a good idea. We can commit these changes. The other things we might need to actually go back to the code base and change things, and then we can at some point re-request a review here if we want to, and then hopefully it will at some point be approved. And when things have been approved, then we will be able to, thank you, we've got it approved. We can say, okay, confirm merge. And then we can delete this branch because otherwise we will have hundreds of branches at some points. And then this one is closed. And you will see that all those changes have been merged into the main branch. Okay. Sam, do you want to do this last bit, or do you want me to?
Yes.
I either way, it's fine. Okay, this is just short closing about, okay, we've gone through what is Git, we've gone through what are repositories, we've done initializations, we've done commits, and now we've done pushes. What we've not done is that any of you now could go and do a Git pull in their repository, and there would get Jillian's changes from her branch back into their version that they have usually locally. These are basically the bread and butter commands that everybody uses on a daily basis when they're using Git and GitHub. So you should be able now to use it locally, just as a version control of your own work, but also how to collaborate and use it with other people on GitHub. And hopefully this will now enable you to go on and learn more or ask more questions and use Git and GitHub. So if you have anything that didn't work for you, or anything that you would now ask as a next step or so, we've got the study room, which is called Anna Bateman. So if you go downstairs and then towards Porter's Lodge, and then further just down that corridor, then there will be the cafeteria on the left-hand side. And then after that, on the right-hand side is the study room. And throughout the week, some of us will sit there and be able to answer your questions, or you can just approach us. I think Dominic also created a spreadsheet. I'm not sure whether it's been posted anywhere where you can request basically a person when they are free. We also have during the year at any time code clinic sessions. So we have a form on our ICCS website that you can fill in if you have any question about code development and research software, and it will come to us, and we will find in our ICCS team the best person or persons to talk to you, and we just create a Teams meeting and chat about your questions there. And also this course and the intermediate Git course, which you might want to look at afterwards, they will all be on YouTube, as the rest of the material or the courses that we are giving this week here. Here is a couple of really good material that you also can look at if you want to learn more about Git or go a bit deeper. There are really good graphical user interfaces that you can use, which makes things a bit more intuitive about, okay, where am I branching off? Where do I go in? It's more intuitive than maybe the command line. So if you're into this kind of thing, you can go here. Here are a couple of other Git courses that you might be interested in. And then that's it from us today. Thank you very much. Remember, at 6 o'clock, the bus goes from Churchill College to Madingley Hall. Don't miss it. And yeah, otherwise, see you all during the week. Thank you.